focus on them.
Okay students, let us go for the next question. Particle undergoing rectilinear motion. Particle undergoing rectilinear motion as its velocity versus distance travelled as shown below. Okay. So when we observe velocity after reaching 50 meters per second, it is constant from 200 to 400. From 200 to 400, velocity is constant, means acceleration 0. So in that case, option 2 and 4 will be ruled out, because for option 2 and 4, it is showing acceleration is constant even after 200 meters, right? But here 200 to 400 velocity is constant, means there is no acceleration. So option 2 and 4 is ruled out. Whereas option 1 and 3, option 1 you can see curve. This is the rate of change of acceleration. Rate of change of acceleration. So but here acceleration is constant between, right, 0 to 200. Hence our option will be 3. Pure theory based question. We'll go for the next question. So next question what is then? If a resistance less rod, so there is no resistance in the rod, is moving with a constant velocity v in a constant magnetic field, then direction of current I1, I2 and resistance R1 and R2. So flux B A cos theta, EMF change in flux with respect to time. Okay, here you can see the rod is moving towards left side. As the rod is moving towards left side, flux is decreasing. Flux is decreasing, right? Then flux should be increased. So induced current will be in what direction? Clockwise. Induced current for in R1 will be in what direction? Clockwise. If you take a circuit in this way, this is, you can expect a cell here, and this is another resistance. This is a resistance R1 and this is a resistance R2. You can expect a cell. Now the current in R1 will be I1, that is what the induced current. Now whereas the current in R2 is I2, so you can see that in R1 it is in clockwise direction, in R2 it is in anti-clockwise direction. So our option will be 1, is based on purely theory based question. We'll go for the next question. Question number 16 is asking output Y. Pure, we got AND gate, AND gate, AND gate, AND gate, NOR gate and 2 NOT gates. What is the input from here? 0. What is the input from here? 0. What is the input from here? 1, because there is a NOT gate, here it will be 0. Right? Again 0 input is going, it will be 1 here. 0 or 1 is 1, again there is a NOT gate, so NOR gate, the result is 0 here. What is the input from here? It is 0, and here also it is 0. 0 and 0 is 0, but there is not an AND gate, so it will be 1. 0 and 1, what will be the output you will get? 0. So your option Y is equal to 0. Purely logic gates, combination of gates. Very simple question. We'll go to question number 17. In a given isosceles prism for minimum deviation means a refracted ray should be parallel to the base. So this is a refraction first surface, refraction second surface. This is I1, this is I2. Refracted ray should be parallel to the base. Check for the option. Ray in the prism is parallel to the base. Yes, ray in the prism is parallel to the base. A is correct. Then incident ray and emergent ray are symmetric. Yes, incident ray and emergent ray are symmetric. So that is also satisfying. Next, angle of incidence is equal to angle of emergence because he said it is an isosceles triangle. So C is also satisfying. But whereas D is not satisfying, so our option will be A, B, C are true. So direct conceptual question it is. We'll go for next question. Question number 18. In the circuit shown in the figure, input source is periodic, its waveform is. Find the reading of the cathode ray oscilloscope, CRO. It is a resistor and capacitor. From T1 to T2, it is charging. From T1 to T2, it is charging. From T3 to T4, it is discharging. So based on that one, the only fourth will be the correct option. We'll go to the next question, question number 19. In YDSC, capital D is 10 meters, distance between the screen and the slits. Separation of the slits is 1 mm, fringe width of the interference pattern is 0.6, that is mm. This is mm. Evaluate lambda in nanometers. So what is beta? Fringe width beta is equal to capital D lambda by small d. Capital D lambda by small d. Fringe width we has given 0.6, that should be in mm, into 10 power minus 3. Capital D value 10. We require lambda small d value 1 mm to 10 power minus 3. So lambda I want in nanometers. So 0.6 into 10 power minus 3 minus 6 by 10. So lambda will be how much? 600 nanometers. So what will get in nanometers? 600 nanometers. So it's a simple direct question based on fringe width. So we'll go over next question. Question number 20. A bar magnet of length 14 centimeters is placed along north-south direction with north of the magnet along north direction. So if I take this as geographical sides, this is north, geographical south. So bar magnet is also placed in this way. Bar magnet is placed. Let us assume this as a bar magnet. North facing, north, and this is south. From the center, we know Earth's horizontal component will be acting in this direction, and if you place a unit pole, these are the field directions because of the unit pole making an angle theta here. This is B, this is also B because of the unit pole. Because of south pole, it is towards the south pole. I am placing a unit north pole here. Repulsion, so B will be that direction. This is theta again. So this is theta again because it makes theta. So what is the resultant? Because here is the null point. What will get here? 2B sine theta. He has given the magnet length 14. So this will be how much? 7 cm. At what distance we require? 18 cm from the center. If I will take this as the center of the magnet. So now we will balance 2B sin theta balancing Earth's horizontal component. 2. B is what? Mu naught by 4 pi small m by d square or r square. BH already has given 0.4 into 10 power minus 4 Tesla. What is asking us? The magnetic moment of bar magnet. Magnetic moment of bar magnet. Capital M is asking. So on simplification, you will get small m. After getting small m, you multiply with length of the magnet. So what will be your capital M? Approximately you will be getting it as 2.88 into 10 power. Calculate and check what you are getting. 2.88 ampere. 2.88 ampere, approximately 2.88 ampere meter square. That will be the magnetic moment. We go for next question. A particle of mass m, so m will be there, rotates in a circle which has vertical boundary of radius. Radius how much he has given? 0.2 meters. Rotating in a horizontal plane, mass of the block he has given 200 grams. It takes 40 seconds. So capital T is how much? 40 seconds. Capital T is 40 seconds in one complete revolution. Find the normal force. So what is the normal force? Equal to centripetal force. M R omega square. Mass he has given, mass of the particle he has given how much? 200 grams. So 200 into 10 power minus 3 converting into kg. Radius 0.2 meters, 0.2. Omega square I can write it as 4 pi square by t square. 4 pi square by t square. T already has given. So this is 0.2 into 0.2 into 4 pi square. I'll take approx 9.8 by t. T is what? 40 seconds. So 40 square is what? So around about what you get? 9.8 into 10 power 0.2, 2 zeros down. So it will be 10 power minus 4 will be your answer. So it will be 9.8 into 10 power minus 4 newtons. Option will be first option. Simple based question. Go for the next question. What is the next question? As per the student's memory, particle m1 of mass m moving with velocity 10 root 3 meters per second. So collides. So we will apply for the conservation. P initial momentum and P final momentum. So based on this one, we will substitute. Initially, mass of this particle is what? M. Velocity is what? 10 root 3 I cap. Should be balanced with final momentum. What is the mass of the second particle? After collision 2m at rest. After collision m1 comes to rest, m2 breaks into two equal fragments such that one part has a velocity 10 meters per second. So one part m into 10 j cap plus one more particle. Then find the angle the velocity vector of the other part makes with x-axis. So this is, we don't know its velocity, we'll go for with v bar. So all the m's get cancels. So velocity vector v bar is equal to what? 10 root 3 I cap minus 10 j cap. So what is the angle it will make? Tan alpha 10 by 10 root 3. So So 10 root 3 roundabout. This is minus 1 by root 3 minus 1 by root 3. So it is making an angle. What is the angle made with x-axis? Is asking the angle with x-axis will be how much? 30 degrees. Angle made with x-axis will be how much? 30 degrees. So we'll go for the next question. What they planet is revolving around the sun in elliptical orbit. In elliptical orbit, what is constant? Angular momentum is constant. Angular momentum is conserved.